Wind is one of the most common natural phenomena we encounter almost every day, yet most people don't actually know what causes it, how it forms, or why it can sometimes be just a soft breeze and other times a force powerful enough to knock down trees, rip off rooftops, or lift entire dust clouds into the sky. But behind every gust of wind lies a combination of solar energy, pressure differences in the atmosphere, the Earth's rotation, and the terrain, all working together to create the invisible but powerful movement of air across the surface of our planet. To understand where wind comes from, we have to start with the sun. The sun is the main engine of Earth's atmosphere, but it doesn't heat the Earth evenly. Some parts of the planet, like the tropics, receive much more solar energy than regions near the poles. This creates temperature differences in the air. Warm air is less dense than cold air, so it rises, leaving behind a low-pressure area. At the same time, cooler air sinks, creating a region of high pressure. And nature always tries to balance things out. Air starts to move from high pressure to low pressure. That movement of air is what we experience as wind. If the Earth didn't rotate and was flat, wind would blow in a straight line from high-pressure areas to low-pressure areas. But the Earth does rotate, and that changes everything. Because of the Earth's spin, we get something called the Coriolis effect, a force that causes moving air to curve. On the northern hemisphere, the air deflects to the right. On the southern hemisphere, it bends to the left. This is why wind on Earth almost never moves in a straight line. It curves and spirals, forming weather systems like cyclones, anticyclones, and massive global circulation patterns. That global circulation is organized into three major wind belts on each hemisphere: the Hadley cell, the Ferrel cell, and the polar cell. These systems move huge amounts of energy in the form of moving air. In the Hadley cell, warm air rises at the equator, flows toward the subtropics, cools, sinks around 30 degrees latitude, and then returns toward the equator as the trade winds, the same winds that powered ancient sailing ships. In the polar cell, cold air sinks at the poles and flows toward the mid-latitudes, where it meets warmer air from the south, creating the polar front, a zone of frequent storms and unpredictable weather. On a smaller scale, wind works the same way, just closer to the ground and in shorter cycles. For example, on the coast, the land heats up faster than the sea during the day. Warm air over the land rises and cooler air from the sea rushes in to take its place. That's what we call a sea breeze. At night, the process reverses. The land cools faster than the sea, and now the air flows from the land back out over the water. These daily winds are strongest in summer and most noticeable at beaches. Terrain also plays a huge role. Hills, mountains, valleys, and even city buildings can block, redirect, or speed up the wind. In the mountains, for example, there's a special kind of wind called a foehn. This happens when moist air rises on the windward side of a mountain, cools, drops its moisture as rain or snow, and then descends on the leeward side as dry, warm air. This dry downslope wind can rapidly raise temperatures and dry out the landscape, sometimes triggering wildfires. It's common in places like the Alps in California. In extreme cases, like thunderstorms, tornadoes, or hurricanes, wind forms because of very rapid pressure changes. Cold, dense air pushes underneath warm, rising air, sometimes violently. This movement can reach enormous speeds. A tornado, for example, can generate winds over 250 miles per hour. Even though these events are localized, their destructive power is enormous. Hurricanes form over warm ocean waters and can last for days, moving across hundreds of miles and affecting entire regions. Wind is, in the end, the result of a delicate balance between air pressure, temperature, humidity, Earth's rotation, and the local geography. Its speed and direction constantly change in time and space. And even though we take it for granted, every gust we feel is the product of countless invisible processes playing out in the sky. Together, they link the planet into a giant living system that shapes weather, affects climate, and helps drive life on Earth. And the next time the wind brushes your face or flips your umbrella inside out, remember, that moving air didn't come from nowhere. It started as energy born in the core of the sun, traveled 93 million miles through the vacuum of space, hit our planet, warmed the land, heated the air, and set in motion one of the most powerful and complex forces in nature. Something we call simply wind. Subscribe us for more videos.